Okay, so in this video, I'm going to be introducing 3 additional components that you can add to your circuits when you're building with Tinkercad circuits and using an Arduino. So the first component we're going to discuss is an RGB LED. So basically this is a LED that can produce any color. It has a common cathode that you connect to ground, and then it's basically 3 LEDs in one. You have your red, your green, and your blue, and you control how much of each color gets turned on to be able to create pretty much any color you want. The next component we're going to talk about is a piezo buzzer, piezo speaker. Okay, pretty rudimentary, but you can apply different voltages across the piezo, and it gets deformed and vibrates in a different way depending on how much voltage you put across it. So you can create different tones by controlling the voltages across it with the Arduino. Okay, and the last component we're going to discuss in this video is a 7-segment display. So the 7-segment displays, you may be familiar with those. Those are used on scoreboards a lot. Old digital clocks use these, and actually you still see them around today quite a bit. But basically, you have either a common anode or cathode. We're going to look at a common cathode 7-segment display, and then you can control each of these segments, turn them on or off, depending on what you want it to display. Okay, so you can create numbers really well with this, and then you can also create letters, sort of. So we're going to take a look at using a 7-segment display as well. Okay, let's first take a look at this RGB LED. So I have set it up to flash through different colors, and I wanted to show the connections here that I've made. So I'm going to stop this while we look at how I've connected it. So remember we said that this is the red lead. So I have connected a resistor in here. I've put in a 180 ohm resistor and connected to the output pin, and created an output pin here, number 2, from the Arduino, that is going to control this red color going to the LED. Okay, the second little leg here is the common cathode for all 3 of the LEDs in there. So I've connected that to ground. That goes to the other side of the Arduino to ground. This is my blue lead. So the blue, if we follow the path here for blue, I have a resistor in here. This resistor is 130 ohms, and it goes to pin 1 on the Arduino. And then finally I have pin 0 is going to be connected here to the green leg of the LED. Okay, so once I have my RGB LED set up and wired correctly, and typically you'll want a little bit more resistance for the red LED, and I have 180, 130, and 130 in this setup. But if you want to take a look at the code here, let's go ahead and look at the code. Basically, I've identified up here that pin 2, and if we look, pin 2 is my red, RGB_R for red. Pin 2, my green was coming out of pin 0, and my blue leads coming out of pin 1. Okay, so here I'm just identifying the pin that controls each of the colors. Okay, and then I'm telling the Arduino here that those are going to be outputs, so you're going to be treating each of these 3 pins as outputs, and telling them to output a certain amount of voltage depending on what I tell it to do in my code. So here I've created a function that is going to, and I've called the function setColor. Okay, and it is going to set the red, green, and blue values for my LED. Okay, so and then it's going to send it out. So it's going to send out a certain number for red, Okay, and I can give that in my function. You'll see I use this set color function down here, and I'm going to give it 3 numbers. Each LED can be in a range from 0 to 255. So if I give it 0 for that color, it's not going to turn that LED on inside that RGB LED. If I give 255, it's going to be on as full. Okay, so I'm giving it kind of all that color. This is very similar if you ever gone in on your computer and just changed color settings using RGB codes. These codes are pretty much the same. You're going to have similar combinations of colors. And it's kind of fun to mess around with the colors and see what values produce certain colors. We could go into the physics of light and why we see certain colors, but we'll leave that for another video. But anyway, so here I've created this set color function, and it's going to take 3 arguments here. And the first number that I give it from 0 to 255 is going to tell the red how much red I'm going to put. The next one is going to say how much green, and the final one is going to tell the Arduino how much color to output, or not how much color, but what voltage to output for the blue. Again, 255 is all the way on, 0 is off. Okay, so in my code, I've created this loop where it's just going to loop through flashing these colors for like a half second. Okay, so it first flashes red, then turquoise, then yellow, then green, then blue, then purple, and then for a brief little bit of time, it's going to turn back off because I've put 0, 0, 0 here. Okay, and it's just continually looping through that. Okay, so we can watch again, start simulation, and it should just loop through those colors. Okay. Okay, so the next thing we're going to look at is adding a piezo to this circuit with a flashing RGB LED. I've set my piezo up here in the top right corner. I have the negative lead connected to ground. Okay, so it's all the way down here on the ground. You can use the same one as you used for your LED, that's fine. And then I have a 100 ohm resistor connected to the positive side, which is then connected to pin 11 of my Arduino. Okay, so remember with the piezo, it's going to buzz according to whatever voltage is given out by pin 11. Okay, and the tone can change. You can change the frequency to change the tone, and you can also change the duration for which it like buzzes. So I'll start the simulation here. I've set mine to try to kind of play a little tune, and then the light buzzes, or the light flashes. So So after listening to that, making this video a number of times, I'm pretty sick of it, but let's go ahead and look at the code for that. So I'll just pull the code out here. So I have the same code that I had for my previous LED circuit with my RGB LED, but I have added now at the top, I've added that I have a piezo pin, and that's pin 11, okay? And then down here, at the top of my loop, I've added this play a tune, where the tone function, and so tone needs basically 2 arguments, but it can take 3. So the first thing you put underneath this function here, this tone function, is what pin it's going to. So we said piezo pin. Up here we had said that that's 11. So this is telling the Arduino, okay, this is gonna be happening at pin 11. Okay, this next one, this 1046, is the frequency in hertz, or how many times per second. So that's gonna determine like the pitch of the tone that you hear. And then this last part, this last number that you give it is going to be the duration, or like how long the tone is going to play for. So it's in milliseconds, so 1,000 would be 1 second. Okay. So here are the different tones it plays, and I looked up the frequency of different pitches, and tried to make it so it kind of sounded nice, because if you just let it if you just randomly assign numbers, it's pretty jarring on the ears sometimes. And then that light flashes at the end while it holds the last tone for 3 seconds. Okay, so this code will be available on the quiz for the quiz section for this week, where you guys have to add one of these 3 components to your circuit. So this will be available for you to look at and alter for yours, so you don't have to copy it all down. Okay, the last new component I'm going to talk about are 7-segment displays. You can see on my screen here, I have a 7-segment display. It has quite a few pins that you're going to need to connect to. Okay, so each of these is labeled. There's 2 that are labeled common. Okay, I am in this demonstration saying that I have a common cathode type 7-segment display, so you need to make sure, if you're going to connect that common, to ground on either side, which I have done. I have the common connected through a resistor, and each of those resistors are 400 ohm resistors, but they're connected to ground. Okay. These are the ones that are on the edges, not in the middle, are labeled with letters. So I'm actually going to show you what those letters are representing. So let's start here with A. So the pin you connect, the Arduino pin that you connect to A right here is going to control this segment of the display. Okay, so the top segment. Okay, B is going to control the top right. C down here is going to control the bottom right. D controls the bottom segment. E, the left bottom. F, which is right here, the left top. G is this middle segment of the display, and DP, the one labeled DP in the bottom right, is controlling the decimal point. So let's go back to the display, and here I have connected everything up, and I've connected, so A is connected to output pin 8 on the Arduino, B connected to 9, F is connected to 7, and G is connected to 6. Then down here on the bottom I have E connected to 5, D connected to 4 if you follow these wires, 3 is connected to C right here, and then this is my decimal point connector, which I'm not going to end up using, but I connected it up anyway, to 2. So again, if you're going to set it up this way, where you're going to treat the Arduino connections here as outputs that produce a high voltage to turn that segment on, and connect the common to the ground, you're going to have to treat this like a common cathode. Okay, I think when it pops out it might say common anode, so if yours is not working and you think you've connected it up like this, check and make sure that it's common cathode. Okay, let's go ahead and see what I've done with the code. So 0, 1, 2, and then it just keeps cycling again. 0, 1, 2, 0, 1, 2. Okay, so let's look at what that code looks like. Click off that. So, okay, so we've set it up, and for my reference at the top, I've kind of written down which pin corresponds to which part of the display. Okay, I've set up all my pins as output pins. Okay, and then I've set up a loop where I just basically identify which output pin I want on for 0, and 0 is going to have 9, 8, 7, 5, 4, and 3 all high, and then that middle pin 6 is low, is not on. So they're all on except for that middle segment. You'll notice I don't have pin 2. I didn't say pin 2 low. I didn't use a decimal point ever, so I just left that one off. Okay, and then I delay for a second or 1,000 milliseconds, and then I make a 1. Okay, so for 1, I just need 2 of the segments lighting up, which is the top right and the bottom right. Okay, both of those are high. Everything else is low. And then when I make my number 2, I have most of it on except for my top left is going to be low, and my bottom right is going to be low right here. Okay, and then it just keeps looping through there like 1,000 times. Okay,